monotonically decreasing function. Similarly, here monotonically increasing function we have discussed in the previous case. No, what is monotonically decreasing function? So the function value will be decreasing with respect to x. Yes or no? So that if you take x1 and x2, x1 is greater than x1 is less than x2, the value at x1 will be greater than the value at x2. This is called monotonically decreasing function. Okay. Now, if you observe for the values y less than y naught, so you are taking the values y less than y naught. So, what are the values included in the function? You see here, we will be having the values x greater than or equal to x naught. If you take y less than y naught, we are getting x greater than x naught. Yes or no? So probability of y less than y naught will be equal to what? Probability of x greater than or equal to x naught. Okay. So now from the total probability theorem, we know that probability of x greater than or equal to x naught plus probability of x less than x naught will be equal to 1. Yes or no? So from that, so we know that probability of x greater than or equal to x naught will be equal to 1 minus probability of x less than or equal to x naught. Okay. So we know that how do you write probability of x less than or equal to x naught? This can be represented by the distribution function. What is that? Fx of x naught. This is the definition. Okay. So it is defined like this only. You have to remember this. Okay. Similarly, probability of y less than y naught. How do we write? We write it as fy of y naught. This is called distribution function. So here y naught you have no. So here we'll be getting y naught, and this y here we have y no variable y. Here also we'll be having y. Okay. So this is probability of distribution function, that is fy of y naught will be equal to 1 minus fx of x naught. Okay. Now we write it in terms of density function. How do you write? So see here, it is integral minus infinity to which term? Y naught here. Y naught fy of y dy. Okay. And similarly 1 minus integral minus infinity to x naught fx of x dx. This is the relation between density function and distribution function. When distribution function is given, the density function can be written as integral minus infinity to y naught fy of y dy. Okay, similarly fx of x naught can be written as integral minus infinity to x naught fx of x dx. Okay. So here just now we have discussed what is x naught. X naught is nothing but T inverse of y naught. Yes or no? X naught is nothing but T inverse of y naught. Okay. Now in the previous case what we did? We differentiated both the sides of this equation with respect to y naught and use Libens rule. Okay. So if you differentiate both sides of this equation with respect to y naught, if you use Libens rule, what we'll be getting on left side? On left side we'll be getting fy of y naught. Okay. So the left side of this equation is fy of y naught. Okay. On right side ma, on right side differentiation of 1 is 0, no? So then we'll be getting this minus sign here. And what is that Libens rule? Just now we have discussed. So first we have to substitute upper limit here and differentiate upper limit with respect to y naught, then minus it becomes plus. Substitute lower limit. If you substitute lower limit, what is fx of minus infinity is 0, so the second term will become 0. And what is the third limit? Third term will be integral minus infinity to t inverse y naught. Di- Partial differentiate this fx of x with y naught. Okay, since there is no y term here in fx of x, so that the partial differentiation is 0, so that the third term will also be 0. So what is that we'll be having? We'll be having only the first term. What is first term? Substitute upper limit in this function. So it is fx of t inverse y naught, fx of t inverse y naught, and differentiate this per limit with respect to y naught. So dt inverse y naught by dy naught. Okay. Now this is for any particular value of y naught. Now in general we write, instead of y naught we will be writing y. If we are writing in general, instead of y naught we have to write y. So this can be written as fy of y is equal to minus a fx t inverse y dt inverse y by dy. Okay. Now we know that what is t inverse y ma? T inverse y is nothing but x, yes or no? So fy of y can be written as fx of x. This minus sign we are applying here because this gives us slope actually. What is this? This gives us slope, okay. That is minus dx by dy, okay. So from monotonically transformation means we'll be having either increasing monotonically transformation, decreasing monotonically transformation. Yes or no? So in that case, what is fy of y? Fy of y can be written as fx of x. Okay. Then mod dx by dy. So what is mod dx by dy? Mod dx by dy will be dx by dy if slope is positive. Mod dx by dy will be minus dx by dy when slope is negative. Okay. So see here for monotonically increasing function. So for monotonically increasing function, the slope is positive. So what you got? Fy of y is equal to fx of x dx by dy. Yes or no? So for monotonically decreasing function, what is that? The slope is negative. So we have fy of y is equal to fx of x minus dx by dy. Only the sign is different here. So in the case of monotonically increasing, here it is plus. For monotonically decreasing, here it is minus. So for monotonically increasing function, this mod dx by dy will be positive. For monotonically decreasing function, this mod dx by dy will be negative.